Good day. Today we'll be looking at sketching curves of polynomials. We'll be applying several of the topics that we've done so far. I did mention in a previous video that when we're sketching curves, we may need to find out where exactly a particular curve will cross an axis. Now these are called intercepts. There is the y-intercept, where the curve will cross the y-axis, and the x-intercept, where it will cross the x-axis. It states, to completely sketch the curve of a polynomial, you need to find the stationary points and determine their nature. We've done that topic. Number 2, find the intercepts, and then finally we're going to sketch the curve. So number 2 is the additional step that I mentioned. So we're going to find the stationary points and determine their nature, and we're going to use the second derivative test for that nature part. So first, stationary points. When we differentiate, we will, from our y function, we will get 3x squared minus 8x plus 5, as you see here. Now, we need factors which, when multiplied, will give us a 15, and when added, gives us negative 8. Now, those are going to be negative 3 and negative 5. So, in place of our negative 8x, we're going to have a negative 3x and a negative 5x. Separate. Factor out what's common, which is 3x, to be left with x minus 1 in bracket. Over here, we'll have to factor out a negative 5 to be left with x minus 1 in bracket again. So now our roots are 3x minus 5 and x minus 1, giving us x equals 5 over 3 and x equals 1 for our x coordinates. You will then plug each into the y function to find the corresponding y coordinates. So when 5 over 3 is plugged into the y function, here I plugged 5 over 3 in place of y. Notice I used brackets to separate because the calculator might not be able to distinguish properly and give you a correct answer. So when we do that, we get negative 4 over 27, which is approximately negative 0.15, as you see here. So we also went ahead and plugged 1 in place of x of our y function to give us 1 minus 4 plus 5 minus 2. And when that's worked out, 5 and 1 is 6. Minus 4 minus 2 is a 0. So we have our coordinates for our stationary points. They are x is 5 over 3, y is negative 4 over 27, x is 1, and y is 0. Now we need to determine the nature. Now recall that our first derivative was 3x squared minus 8x plus 5. So when we differentiate that, we'll get for our second derivative 6x minus 8. We'll then plug each x value into that function to see if we'll get a positive or a negative. So when 5 over 3 is plugged in place of x, 6 times 5 over 3 is 30 over 3, which is 10, and our minus 8 gives us a positive 2, making the stationary point where x is equal to 2 a minimum. When the 1 is plugged into the second derivative, 6 times 1 is 6 minus 8 is a negative 2. So at x equal 1, the stationary point is a maximum. We did say wherever the curve will cross an axis, that's where the intercepts will be formed. So let's say we have a curve like that. This is our y-axis and this is our x-axis. The curve cuts the x-axis at these 2 points, and at these 2 points the value of y is 0. Anywhere along this x-axis, y is equal to 0. In that case, if we let the y value become 0 and equate the function to 0, we'll be able to determine those x values where the curve will cut the axis. The same principle for the y-intercept. This is where the curve cuts the y-axis, and anywhere along here, x is equal to 0. So if we make x 0, we'll be able to find that y value. Let's see what we mean. So first we're going to find the x values. We're going to make y equal 0. As you see here, I'm making f of x or y 0. We are working with a cubic polynomial. We have the cubic polynomial y equals x cubed minus 4x squared plus 5x minus 2. You will be familiar on how to factorize a quadratic. With a cubic polynomial, it's slightly different. It means that there are 3 x values that can solve this equation. Now, in order for us to do that, we first have to do a simple trial and error. You will find an x value that will make the function 0. So you can start at 1, plug 1 into the function, see if you get 0, then -1, 2, then -2. In most cases, you don't usually do more than 3 trials, 3 or maybe 4 trials. Now, one of those values is 2. Now, if I plug 2 in place of x here, 2 cubed is 8, 2 squared is 4, and 4 is 16. 5 times 2 is 10, and this -2 goes back. So here we have 8 minus 16 is -8. -8 plus 10 is 2, and 2 minus 2 is 0. So we have found one value. We have found one x value that will make this entire function 0, and that value is 2. So therefore, if x is equal to 2, then a factor, when we bring this over, is going to be x minus 2. So x minus 2 is going to be our first root of our equation. Recall when we're doing quadratics, we end up with 2 roots. With the cubic polynomial, we're going to end up with 3 roots, and this is our first root, x minus 2. Now we have our first root. We're going to have to find the remaining 2, and to do that, we're going to divide that known root into the cubic polynomial. We're going to apply long division. Recall from primary school, from your long division, it's the same steps, but there's just an additional step because we're not only dividing by 1 but 2 values. So let's go ahead. First we will say x into x cubed will be left with x squared, and then our x squared times x is x cubed. That's our normal approach in long division. Now we have to also multiply our x squared we got by this -2. So let's go once more. X into x cubed, x squared. X squared times x, x cubed. And x squared times -2, -2x squared. We'll then subtract. So we are subtracting all of this. So x cubed minus x cubed is 0. So now we have -4 minus -2x squared. So that gives us -4 plus 2, which is a -2. So we are left with -2x squared when we subtract. We'll then bring down this next variable, this next part of the function, which is the 5x, and we do it once more. X into negative 2x squared, you'll be left with a negative 2x. Then we multiply. Negative 2x times x, negative 2x squared. Negative 2x times negative 2 is a positive 4x, and we'll subtract once more. So we have negative 2 minus minus, which is a plus 2, that's 0. And we have 5x minus 4x is an x. We'll then bring down the next part of the equation, which is our negative 2. And once more, x into x is 1. So 1 times x is x. 1 times negative 2, negative 2. Remainder 0. I know that was long and maybe a bit tricky, but that's the approach. So here, we've divided our known root into the polynomial to be left with this up here, which is a quadratic. And we will then have to solve that quadratic to get the remaining 2 roots. Now we will factorize that quadratic that we found. 1 times 1 is 1, so factors are going to be 1 and 1, but since we need a negative 2, they're going to be negative 1, negative 1. So when we separate x squared minus x, x is common to be left with x minus 1. Factor out a negative 1 to be left with x minus 1 once more. So if you notice, the roots are the same, which means that the x value, when we equate it to 0, we have x equals 1. So we've now found the points where the curve will cut the x-axis, which are at 1 and 2, which we found earlier. So those are the x-intercepts. Now for the y-intercept, we will make the x value 0. So when we do that, this is our polynomial. I just dropped it there. We'll get a 0 here, as well as here and here. So we're left with negative 2. So therefore, the curve will cut the y-axis at negative 2. So just to summarize, we found our coordinates. We had x is 5 over 3 when y is negative 4 over 27, and x is 1 when y is 0. This stationary point when x is 5 over 3 was a minimum, and this one was a maximum. And the curve will cut the x-axis at 1 and 2, and the y-axis at negative 2. So let's put all of that information on a graph. So we have our scale going up to 2 on the y, 2 and negative 2 on the y, and down on the x as well. So first, our stationary points. We had 5 over 3, which is approximately 1 and 2/3. So we have, here is 1, that's 2. So I divided this space into 3 equal parts. So that's 1 and 1/3, 1 and 2/3, which is here. And then the corresponding y value was negative 4 over 27, which was approximately negative 0.15. And that will be where negative 0.15 will fall. So along there to where x is 1 and 2/3, or 5 over 3, is our minimum. 5 over 3, negative 4 over 27. And then for our maximum, which was 1, 0, so we find x is 1, y is 0, which is right there. So we put our frown right at that point. So maximum stationary point, minimum stationary point. I know they are close, but we have to take into account the intercepts that we found earlier. So based on our calculation, the curve will cut the x-axis at 1 and 2. We already have it here, so that one is out of the way. Now for 2, it's right here. Cuts the x-axis here and at 2. And then for the y-axis, it will cut it at -2. So that's why when you connect these free ends from the maximum to that end of the minimum, this end of the minimum goes up and crosses x equals 2, while this end of the maximum will go down and cross y equals -2. So your curve ends up looking something like that. Now for a question that we're going to do together, we're going to sketch the complete curve of y equals 3x cubed plus 5x squared minus 16x minus 12. First we need the derivative dy dx, which will be 9x squared plus 10x minus 16. We'll equate it to 0 and find values that will give us a positive 10. Now when we multiply 9 with -16, we'll get -144. And then the factors to give us a positive 10 will be a positive 8 and a positive 18 and a -8. So I'm going to plug those in place of my 10. So we have a 9x squared. I'm putting the 18 next, so I can have it with my 9, plus 18x minus 8x minus 16. Separate, factor out the 9x, which will be common, to be left with x plus 2. And we have to factor out a -8 on this side to be left with x plus 2 in the bracket once more. So our roots are 9x minus 8 and x plus 2 is equal to 0. Making our x values, this comes over as a positive 8, 9 comes over and gets divided. This x comes over. This 2, comes over as a -2. So these are our x values. We're now going to plug each into the y function and find the corresponding y coordinates. When 8/9 is plugged in place of x in our y function, we get that, which is approximately -20.16. We're going to put -20. And when -2 is plugged in place of x in our y function, we end up with 16 as our y. So we now have our coordinates for our stationary points. 8/9, -20, and x, -2, y, 16. We now need to find out what type of stationary points they are, and we're going to use the second derivative test. So our second derivative will be from this 18x plus 10, and we will plug each of our x values to determine what type of stationary point we end up with. So when 8/9 is plugged in place of x right here, cancel, leaving 2, 2, 8, 16, 16 plus 10, 26. And here, when our -2 is plugged in place of x, this will give us -36 plus 10 is a -26. Therefore, since this value is positive when x is 8/9, that stationary point is a minimum. And this one, when x is -2, since we get a negative answer for a second derivative, that one is a maximum. we found our stationary points and their nature. Now let's find out where the curve will cut the axes. Now for the y-intercept, which is where the curve will cut the y-axis. The curve will cut the y-axis here, anywhere along here, x is 0. So we're going to let x be 0 and plug it into the y function. When we do that, we'll get 0, 0, 0, making it a negative 12. So the curve will cut the y-axis at negative 12. For the x-intercept, which is when the y value is equal to 0, this is where we do the long division. Now, this is our polynomial, and remember, if you recall, we first need to, by trial and error, find a value that will make the function 0. One of those values is 2. When you let x be 2, here, 2 cubed is 8, 8 threes, 24. 2 squared is 4, 4 fives, 20. 2 times negative 16 is negative 32, and the negative 12 comes down. So here we have 44, a positive 44, and a negative 44, which is equal to 0. So when x is equal to 2, or y is 0, which therefore means our first factor is x minus 2. We're going to divide that into our polynomial. X into 3x cubed is 3x squared. Multiply 3x squared by x, 3x cubed. 3x squared by negative 2, negative 6x squared. We're now subtracting. That will be a 0, and then 5 minus negative 6 will be a positive 11x squared. This negative 6x is brought down. Doing the step once more. X into 11x squared is a positive 11x. Then we multiply 11x times x, 11x squared. 11x times negative 2, a negative 22x. Subtract once more. That's a 0. Here we have, I should have brought down a negative 16. So we have negative 16 minus negative 22, or negative 16 plus 22 is a positive 6. X, we bring down our negative 12, and once more. X into 6x is 6. 6x, 6 times negative 2, remainder 0. So this right here is the quadratic that we're left with, and we'll now solve. Three times 6 is 18. The factors are going to be 2 and 9, a positive. So 3x squared plus 9x plus 2x plus 6. Factor out 3x, left with x plus 3. Factor out a 2, left with x plus 3 once more. So we have 3x plus 2 and x plus 3, which makes the other two x values a negative 2/3 and a negative 3. Therefore, our curve will cut the x-axis at 3 points. 2, negative 2/3, and negative 3. Next, we will sketch our curves. So we have our stationary points. They were x is 8/9 and y is negative 20. And when x was 8/9, that was a minimum. We also had x is negative 2 and y is 16. That one was a maximum. Our curve should cut the x-axis let's put x-intercept. A curve should cut the x-axis at 2, negative 2/3, and negative 3, and cut the y-axis at negative 12. So let's put all that information on our graph. Based on these values, we can bring our graph up to, this was in negative 20, my apologies. We can bring our graph down to negative 20 and up to 16 on the y. And this is a 1 and negative 2. Our intercept included a negative 3, so we have to go as far as negative 3 on the x, and we can go up to 3 on the positive side as well. So first, our maximum, negative 2, 16. So you go across to x is negative 2, then up to y is 16. That's our maximum. For our minimum, it was 8/9 to negative 20. So here we have x is 1. Now if we estimate and break this into 9 equal parts, it will fall somewhere here close to 1, and you will go down to negative 20. So you go down to somewhere here for your minimum. Now for the cuts, the graph should cut the x-axis at 2, negative 3, and negative 2/3. I separated this into 3 equal parts, so that's negative 1/3, negative 2/3, negative 1, so negative 2/3 is right here. And our y-axis needs to be cut at negative 12. So we can connect from our maximum. This end will go down and cut x-axis at negative 3. This end will go down and cut the x-axis at negative 2/3. Continue down, cut the y-axis at negative 12 to meet the next end of the minimum, while this end of the minimum will go up and cut the x-axis at 2. So your graph ends up looking something like that.